Hello and welcome back to Mr. Lamb's Science Corner. Today we're going to do a demonstration. It's a real easy demonstration because I hear people say I can't do demonstrations. Because like this, and I'm trying to show you that it really isn't that difficult to do at least some of these. I will admit some of the demonstrations are you've got to put together equipment from here, there, and everywhere. You've got to buy this and that and all like this, but this one is real simple. There is a glass of water in front of me. I have in my hand a food coloring thing, and I wanted this one because I can put like a drop in. And what I'm going to do is, having let this sit still for a while, I'm going to put one drop, hopefully, of food coloring in there, and it starts spreading out. And the reason I do this is twofold. One is it shows the property of something called diffusion, and diffusion is something that happens with basically all different kinds of matter. We have three main kinds of matter. We have solid, liquid, and gas. And in the liquid, it's the easiest to see diffusion because I take a liquid drop of food coloring, put it into water, and it starts spreading out. We also experience diffusion in gases, in that if I was to take some perfume here and spill it onto the tabletop, within a few minutes, my son, who's the cameraman today over there, would be smelling it. And I would smell it sooner because I'm closer to the thing. Now, this is not to be confused with mixing. Could I take a pencil or a stirring rod or something, or even my finger, and stir that up? And the answer is yes, I could. That's not diffusion. Diffusion is when you put it in and leave it alone, and it will spread out. What this is showing is, and it's such a simple little demonstration that it doesn't seem like it has a powerful meaning, but it really does, because back far enough in the past, not too terribly far, called 200 years, roughly about the time that we became a country, there was a huge argument going on in scientific worlds as to whether matter was static and didn't move, or it was moving. And the word that we use for that is kinetic. And I probably should write that down in case you're not familiar with the term, although you probably are. You just really raged there, because everything that they knew about properties of matter could be explained with the kinetic theory or the static theory. And it wasn't until Albert Einstein came along, in which he used the kinetic theory to explain how molecules, atoms, had to exist, and that they had to be in motion. And it was through something called Brownian motion, which since 1837 had been described but not explained. And lots of people tried to explain it in the 1800s, but it took Einstein in 1905 to explain it, and like I said, in the process proved the existence of atoms, which had not been completely accepted. A man named Ernst Mach, who we know from Mach 1, Mach 2, Mach 3, the speed of sound, was one who was an atom denier. And he eventually came around because the proof that Einstein gave was Einsteinian. So anyway, the diffusion that we have here is more easily explained through the kinetic theory. So this is a demonstration, and the interesting thing is that it also can be used as a lesson to tell the students that not all things happen very quickly. That this diffusion probably should wait several hours before we do it. So I'm not going to let the tape run that long, mind you. We're going to cut here pretty quick, and then we're going to come back. It properly should take, you set it up one day and leave it sit on the shelf for the next day when they come back and check it. Interestingly enough, diffusion also exists for solids. And they've actually done this demonstration, talking about time. They took a piece of lead and they took a piece of gold and they slapped them together carefully, tied them up, we might use rubber bands or something like that, and hucked it into a drawer for 20 years. Years. And at the end, they very carefully pulled them apart, and kind of like the old commercial about peanut butter and chocolate, they found some lead in the gold, and they found some gold in the lead. That there had actually been some diffusion, very, very slow, very small amounts, but still there in solids. So we've shown diffusion for gases, for liquids, and for solids, although if you're going to do it for solids, the kids better plan on coming back for a reunion. So anyway, so we have that, and so this is a demonstration that is very simple, powerful in that you can show the kids, you know, if you talk about atoms and whatnot, you can talk about how they argued back and forth over whether atoms existed or not, whether they moved or not, and then you can show them this diffusion and show them that the atoms have to move or it wouldn't go from mostly here on the bottom to all the way through. And like I said, we're going to cut now and we'll come back. Okay, welcome back. Some time has passed, and we now have the red food coloring pretty evenly distributed throughout. Now, like I said, this normally would take several hours to. I would probably plan on being overnight. Just do something, you know, for the kids. Maybe right towards the end of the day, and then they come back in the morning and said, okay, there it is, or however you want to work it. But diffusion is something that helps show, doesn't prove, but it helps show the kinetic theory of gases, liquids, and solids. Okay, and so with that, the easiest, simplest demo on earth. Thank you very much. We'll see you later.